All right, ladies and gentlemen, welcome back. So we are going to continue moving forward through the Cladogram practice problems, and this time we're going to pick up looking at some slightly different data. So rather than looking at characteristics and the character tables based on do they have wings, do they have feathers, that kind of thing, now we're going to take a look at molecular data. So below in the table, we have the number of DNA nucleotide differences. All right, so how many things in their DNA sequence are not the same? Given the species, and in this case, we're just going to use some basic A, B, C, and D for a particular muscle fiber protein called myosin. So we're looking at, again, at DNA differences, how much of their sequence is different between the given species that we're looking at. And in this case, we're just going to use those general letters for this particular protein. And for a lot of kids, if they understand and figure out how these work, these molecular data tables often end up being easier to create tables for than the derived character tables we've been doing so far, because in this case, there's no characteristics you have to add. You just need to figure out the order of the organisms. Um, so if we take a look at the table, right, we're comparing one species to another. So across the row versus up the column, where they meet is the number of things that they have that are different from each other. So if you look for comparing species A to species A, there's no number because they're the same species, and thus that would mean that they would have no differences between the two of them because they are the same species. I come down here to letter B, species B compared to species A, I have 20. Species C versus species A, there's 60, so on and so forth. And then this side of the table is grayed out because it's essentially a duplicate of what's down here. So no point in giving you the data twice. All right. So the way that I like to approach these is to find the biggest number in the table. And in this case, that's that 100 that I see right here. And so what that's telling me is that there's 100 differences between sequences for species D and sequences for species A. So what does that ultimately tell you? Well, that tells you that they have the biggest number of differences between their sequences, which means they have spent the most time apart in terms of when their speciation event occurred. When did they diverge from their common ancestor? And so what that translates to on a cladogram is that these guys have to be the furthest apart from each other. So that's going to mean that species A is going to come down here, and species D is going to be up here at the other end. All right, so that means I now have these two guys on that table. So now I can work from either species D's information or species A and look for the smallest number of differences to tell me which one is going to come next. So I'm going to work with that first column here, all right, because that's where most of the data is anyway. So if I look for the smallest number of differences here, the smallest number is 20. And that 20 comes between B and A. So A is already on the cladogram. And if they have the smallest number of differences, that means their divergence point had to have come relatively close together. And so that tells me that species B has to be the next one on that cladogram. So let's do the same thing then. I'm going to stick with letter A. Next number bigger is C for 60, so that means that C comes next. All right. And then the last one is that 90 for letter E, and that means he comes there. And you're done. Because there's no derived characters, it's just numbers of differences in a sequence. We don't have those derived characters that we need to add to the table, and so we can be done. We move on. Okay, so let's take a look at this one. So again, I'm looking at the number of differences in the first 60 amino acids of a neuromodulin protein isolated from 5 species. And then I've got the table data below. All right, so again, I'm looking at these different species. I have the number of differences between them. Because I'm comparing the same species here, that's why that 0 exists. And these guys are grayed out because you already have the data over here. Okay, so Where do I start? Well, remember what I said last time. Find the biggest number of differences between species, and then you can start figuring out where they go. So if I come up to the table, the largest number is 13. So that tells me that those zebrafish and those frogs have to be on either end of the table, or from the cladogram, I should say, from each other. So I'm going to go ahead and put the frog down here, right, and put that zebrafish up top here. So now I've taken care of that zebrafish, all right, and I've taken care of the frog. Okay, so I'm going to stick with one of those species, and you can kind of take your choice from there. Let's just look down that zebrafish column because it's got the biggest number of data points there. So if I look, all right, so between the frog and the zebrafish, there was 13 differences. The next number there is 11, but that 11 occurs both in the gecko and the turtle. So how do I get both of those guys to be the same distance from the organism? And the answer there is that they have to exist on the same line. All right, so if I look, all right, I've got 11 from the zebrafish, which means they're going to come back down here. Okay. And in order for them to be the same distance from that zebrafish, they have to branch off of each other. So let's go ahead and put that turtle on there, all right, as well as the gecko. Okay. So those guys are taken care of. And if you look, all right, they are the same distance from a lot of other species, and so that tells you that you're on the right track. Okay, the only guy left is that finch. So if I come back to that zebrafish, he's 10, so he's a little bit closer than everybody else, and so he's going to go right here. And you've taken care of all the species, so you're done. All right, so let's take a look at this one. Based on the data in the table, draw the phylogenetic tree that reflects the evolutionary relationships of the organisms based on the differences in their cytochrome C amino acid sequence. So we're going to do the same thing. All right, we're going to go ahead and draw on that cladogram. All right, and I've got the same basic data. So when I look at horse to horse, right at 0 because they're the same species, the grayed out boxes are data that you already have over here. So give this one a shot yourself, see how you do, and when you're finished, come back and let's talk through it. All right, guys, welcome back. So I'm going to take the same approach that I've been doing thus far. What's the biggest number in the table? And if I look across, hopefully you found that 21 was the biggest number, and that occurred between the snake and the horse. So that means that these guys have to be on opposite ends from each other. So I'm going to happen to put the snake down here and the horse up top here. All right, so that means my horse and my snake are taken care of. Okay, I'm going to stick with that snake. All right, and take a look down the column. And if I look, the next biggest number is the donkey with 20. All right, and that means that that is between the snake and the donkey, so that means that he's got to be closer to that horse, so he's going to come up here. And we've taken care of the donkey. And if you look, that data matches. There's only one difference between that horse and that donkey, so that makes sense. He should be close. All right, moving down the table, next biggest number is the chicken. So that means that chicken is going to come next. Right, and then your penguin comes here. And we've taken care of all the species, so we're done.